Hello and welcome to our next lesson on this topic of sound that we've been covering in science. Last lesson we looked at loudness and pitch. We looked at how the change in amplitude and the change in the size of the wavelength or the frequency changes how high or low a sound sounds, as well as the volume of that sound. Today we're going to look at some different ways by which we can detect sound. So our title today is Detecting Sounds. You need to write that at the top page of your exercise book, please. We can put the date. By the end of the lesson, you should be able to tell me how the ear works. You should be able to tell me how your hearing can become damaged. And you should be able to compare how a microphone works with how an ear works. So, again, write today's title and we'll make a start. If at any point during this lesson you feel you're falling behind, you can always pause the video, rewind, just to make sure you get all the points that you need. So first things first, I'm going to steal this image so that we can write it on here. And we're going to start by writing in red, because it's very important, that our ears detect sound in our environment. Okay, so our ears detect sound in our environment. And for your exams and for year 7, you need to be able to say what each part of the ear does. So I'm going to put this in the center of the page and we're just going to annotate it. You have got this diagram in the PowerPoint that I've given you. Okay? So the outer part of your ear, the bit that you see sticking out on the side of your head, is known as the pinna. Okay? I've got cauliflower ears, as I'm sure you're well aware, and this is my pinna that is scarred, and it sort of changes the way that my ears detect sound. My ears will not pick up sound as good as yours will, because you have a perfectly shaped pinna to pick up sound from your environment. So we can start by saying, and I'm going to circle them in colour so you know what I'm defining, that the pinna is the outer part of the ear, outer part of the ear that detects sound waves, and directs them to the auditory canal. So your pinna is the outer part of your ear that detects sound waves and directs them to the auditory canal. Okay? Now, the auditory canal, the pinna, and the eardrum make up your outer ear. So we can say over here, I'm not going to label anything, we can say that the outer ear is made up of the pinna, the auditory canal, the eardrum, and the eardrum. So your outer ear is made up of the pinna, auditory canal, and your eardrum. The auditory canal is sort of a tube that directs the sound waves towards the eardrum. So the auditory canal, we can say, is a tube that directs sound waves to the eardrum. So the auditory canal directs sound waves to the eardrum. The eardrum is just a thin sheet of skin which sound waves bang upon. Okay? So we can say that the eardrum is a thin sheet of skin, thin sheet of skin which sound waves bang upon. So when we hear a sound, the sound waves are picked up by our pinna, go down our auditory canal, and they bang on our eardrum. So that's our sound wave. Okay? Once the eardrum vibrates, it causes some bones known as the ossicles to vibrate. So our next one we need to define, I'll use this colour here, is the ossicles. And we can say that these are tiny bones. In fact, they're the smallest bones in your body, and when you're born as a baby, they're already full size. They never get any bigger. So they're tiny bones that vibrate when the eardrum vibrates. Okay, so they're tiny bones that vibrate when the eardrum vibrates. These amplify the sound. So we can put these amplify sound. So the ossicles in your ear, the tiny little bones, amplify the sound. When the ossicles vibrate, they cause movement inside the semicircular canals. Now, the semicircular canals cause liquid inside of the cochlea to vibrate. So we can say that the cochlea, which colour haven't we used that we could use? Try this one. So the cochlea contains liquid and hairs, full stop. When the liquid vibrates, it causes the hairs to generate an electrical signal. So it causes the hairs to generate an electrical signal. Okay? Once these generate an electrical signal, these send a message to what's known as the auditory nerve. Auditory nerve, which is this one here. And we can say that the electrical signal from hairs in the cochlea, electrical signals from hairs in the cochlea are passed to the auditory nerve, which sends the impulse to the brain, which sends impulses to the brain. And that's the auditory nerve. So, our ears detect sound in our environment, okay? The pinna is the outer part of the ear that detects sound waves, okay? These carry the sound waves from the pinna down the auditory canal to the eardrum. The auditory canal is just a tube that directs the sound waves to the eardrum. The eardrum is a thin sheet of skin which have sound waves bang upon it. When the sound waves bang upon the eardrum, these cause the ossicles to vibrate. The ossicles are the tiniest bones in your body which cause vibrations. This causes the sound to be amplified. This passes on the message through what's known as the semicircular canals all the way through to the cochlea. The cochlea contains a liquid as well as hairs that line the inside of the cochlea. When the liquid vibrates, it causes the hairs to move and generates an electrical impulse. Okay? This electrical impulse is sent to your auditory nerve, which then goes to your brain, where you make sense of the sound. So we've already said that your outer ear is made up of the pinna, auditory canal, and the eardrum. The ossicles make up your middle ear. So your middle ear is getting late, sorry, is the ossicles, while the inner ear is the cochlea and the semicircular canals. So the inner ear is the semicircular canals and the cochlea. Okay? So if we have a look back at our learning objectives, you should now be able to tell me how the ear works. You need to know what all these parts do and where they're found. You need to be able to tell me how these bring about sound. If you're not sure about that, start the video again, or do your own research. Have a look on YouTube, have a look in textbooks, see what you can find online. There's lots of activities that you can use to do that. Okay? So, we need to now talk about how your hearing can be damaged. Okay? So, let's just refresh our screen and put the subheading, how can you damage your hearing? How can you damage your hearing? Question mark, and we can underline that. Okay. Now, sound is measured in decibels. So sound volume is measured in decibels. Okay. Now, you can damage your hearing a number of ways. Very loud sounds can damage your hearing. So, loud sounds can damage your hearing. Okay? At the same time, head damage or damage to your head can start to cause hearing damage. Okay? So head injuries, damage hearing. We can have a build-up of earwax. Damages hearing. We can say sharp objects putting a hole in your eardrum can damage your hearing, but your eardrum will grow back. So sharp objects piercing the eardrum will damage hearing. Okay? Now, these are all ways that your hearing can become damaged. So loud sounds can damage your hearing, head injuries can damage your hearing, a build-up of earwax, sharp objects piercing in your eardrum. However, your eardrum will grow back. The final thing we need to do is comparing how a microphone works to how an ear works. So we can put the subheading, how does a microphone work? Question mark. And we can take an image off the PowerPoint that I had saved to use in lesson. And we can make it a lot smaller. If you want to see bigger, it is on the PowerPoint that I gave you. Probably make it a bit bigger than that. There we go. So this is essentially a diagram showing how a microphone works. When sound waves are detected, it causes what's known as a diaphragm to vibrate. Okay? So we can say that, first things first, sound waves cause a diaphragm to vibrate. Okay? When it does this, it causes an electrical impulse. Okay? It causes an electrical impulse that is passed down some wires to a speaker so that the sound is amplified. So the vibrating diaphragm causes an electrical impulse to be generated and sent to a speaker. And that's all you need to know for now. Okay? So you should now be able to tell me how the ear works. You should be able to tell me how your hearing can become damaged, and you should be able to compare how a microphone works with how the ear works. I've purposefully avoided doing that because that's going to be one of the questions you need to do. So, what I would like you to do, please, I would like you to pause the video at this point, and I would like you to start having a go at the questions on the screen. For question 1, you need to write out the question, filling in the gaps. For question 2 and 3, you need to write the question out in your book before answering it. So I would like you to fill in the gaps for the first one. For the second and third one, write out the question before answering it. Make sure you've got a different coloured pen available because we are going to go over the answers, and I do want you to mark and correct your work as we do that. So pause the video now, get a different coloured pen, and press play once you've had a go at all 3 questions. Okay, so you should have had a go at those questions by now. If you haven't had a go at the questions, why are you pressing play? I want you to have a go at all of them before we go over the answers. So let's have a look at this first one. Let's have a look at it. Let's make it a bit bigger so that I can write my answers in. So, where's my pen? So, it should read that when sound waves enter your ear, it makes the eardrum vibrate. Eardrum vibrate. This makes the ossicles vibrate. The oval window if you don't know what that is, you need to go and research it, vibrates, and this makes the liquid inside your cochlea vibrate. Cochlea vibrate. Cells at the base of hairs inside your cochlea produce an electrical signal that travels up your auditory nerve. Auditory nerve to your brain. Sound intensity is measured in decibels. Decibels. Your hearing can be damaged by loud sounds. In a microphone, a diaphragm vibrates, which produces an electrical signal. So your answer should have read, when a sound wave enters your ear, it makes the eardrum vibrate. This makes the ossicles vibrate. The oval window vibrates, and this makes the liquid inside your cochlea vibrate. Cells at the base of hairs inside your cochlea produce an electrical signal that travels up your auditory nerve to your brain. Sound intensity is measured in decibels. Your hearing can be damaged by loud sounds. In a microphone, a diaphragm vibrates, which produces an electrical signal. Let's grab these second questions and paste them in. We don't need these as big as these ones were. Perhaps a bit bigger than that so I can actually read it. So, the first question says, or second one, describe one way that your hearing can be damaged that is not permanent and one way that can be permanently damaged. So, for your non-permanent ones, so for number 2, non-permanent. You should have said earwax, so too much earwax. You could have said piercing the eardrum, so piercing the eardrum. We did say that it can grow back if you pierce your eardrum. And finally, we can say an ear infection. Ear infection. Permanent ways that you can damage your hearing. So permanent ways that we can damage our hearing include listening to loud music, listening to loud music, and we could also say head injuries. Head injuries also cause permanent damage to your hearing. Okay? So any two of those, you must have one non-permanent and one permanent to get both marks. Question 3, our final one, which is quality of written communication. So you need to write your answers in full sentences. It says compare the ear and the microphone. So how do they work? What are the similarities? What are the differences? So for 1 mark, you could have said that they both detect vibrations. So they both detect vibrations. You could have said that they both produce an electrical signal. So they both produce electrical signals. For another mark, you could have said that the ear contains bones, membranes, and liquids. So the ear contains bones, membranes, liquids, but the microphone does not. You could have then gone on to say that the ear amplifies sound, but the microphone does not. Remember, a microphone needs a speaker. So ear amplifies sound, but the microphone does not. But the microphone does not. You could have said that a microphone contains magnets, but then an ear does not. Microphones contain magnets, but the ear does not. And finally, the microphone can be attached. No, sorry, we've already had that, haven't we? The ear contains cells. Ear contains cells that produce electrical messages. That produce electrical messages, but the microphone does not. So these would have all given you marks. They both detect vibrations. They both produce electrical signals. The ear contains bones, membranes and liquids, but a microphone does not. The ear amplifies sound, but a microphone does not. Microphones contain magnets, but the ear does not. And ears contain cells that produce electrical messages, but microphones do not. So you should have marked all of that by now. If you have any questions, please drop me an email or write a comment in the Google Classrooms. You should now be able to describe how the ear works. You should be able to describe how your hearing can be damaged, and you should be able to compare how a microphone works to how an ear works. I will see you in the next lesson. Ta-ra.